Now when we are comparing exponents, we need to understand one thing, which is, let's say on this number line, x is somewhere on this area, x is more than 1. So for example, x is equal to 2, 3, 4, anything more than 1, x square will be more than x for sure. If x is negative, still x square will be more than x, because x square will be positive and x would be negative. Positive is bigger than negative. But if x is between 0 and 1, the exponents behave totally different. Let's say x is 1 by 2, so x square will be 1 by 4 smaller, x cube will be 1 by 8 even smaller, so the values will keep decreasing. So wherever you're comparing x square and x, wherever you're comparing exponents, it's very important to take a value between 0 and 1, because that will give me a totally different result. Okay, so if we see here, let's take one thing at a time. Let's say x is greater than y square. Let's say 26 is greater than 25. So x and y in that case would be 26 and 5. So x is bigger than y. X bigger than y square, let's say, is 1 by 3 greater than 1 by 4. So again, x and y in that case would be 1 by 3 and 1 by 2. X is smaller, and x bigger than y square, let's say 1 by 2 is bigger than 1 by 4. So x and y would be equal in that case. Okay, so x can be bigger than y, x can be smaller than y, x can be equal to y. All three inequalities are possible. These two inequalities would look little less plausible. They are happening with fraction values when x and y are between 0 and 1. Same way, y square greater than z raised to power 4, the situation is exactly similar to this. So it could be y greater than z, y less than z, y equal to z. All things are possible. Answer here is E. All kinds of inequalities are possible. For this question, when we compare x square and x, you must take a value between 0 and 1, like 0.5. You must take a value greater than 1, which is like 2. These will give me opposite results. This will give me x square less than x. This will give me x square more than x. So we must check with these two values. Again, when we are comparing with x and 1 by x, at x is equal to 1, they are equal. So we must take a value which is like slightly to the left of 1. Let's say x is equal to 0.9. In this case, 1 by x would be bigger. And we must take a value which is slightly to the right of 1. Let's say x is equal to 1.1. Here x will be bigger than 1 by x. So the crux of this whole thing is, you must take values like 0.5, 0.9, 1.1 and 2. Okay, this will give me possibilities of all the cases. In this question, it's asking me which of the following could be correct. Okay, I just need one value where the inequality would be correct, and I'll take it. First says x square is more than 2x. X square is less than 2x less than 1 upon x. So at x is equal to 0.5, it will be 0.25, 1 and 2. So the inequality holds true. So this can be true. Okay, I've taken one value where it is true, so it can be true. Second, x square less than 1 upon x less than 2x. Now if you see 2x and 1 upon x, they have interchanged their positions here. So clearly 0.5 won't satisfy it. Now we check with 0.9. So at x is equal to 0.9, it will become 0.81, 1.1, 1.8. So this can also be true. Third, 2x is less than x square less than 1 upon x. Now again, x square and 2x interchanging their positions, so 0.5 would not satisfy it. And same way here, if we look at this point, x square 2x, they're interchanging their position, so 0.9 will also not satisfy it. So values smaller than 1 won't satisfy it. That's pretty much clear. Now we need to take values more than 1. If x becomes more than 1, let's say x is equal to 2, this will be 4, 4, 1 by 2. Now the number which is supposed to be largest in this inequality will become smallest because it's in the denominator. So as we keep increasing the values of x, this will become even smaller and smaller, and this inequality will never get satisfied. So this is your answer, D. For this question, let's say a upon b is positive. So it could be positive upon positive or negative upon negative. Both the signs must be same. So if we are checking, is 1 upon k positive? See, 1 is already positive. Okay, it's fixed number, it's positive. Upon something should be positive. That means that something should also be positive. So we are simply checking, is k positive? That's our question. First statement, 1 upon k minus 1 is positive. Again, numerator is positive, so denominator must also be positive. So k minus 1 is positive, k is greater than 1, and greater than 1 means it's positive, sufficient. Second statement, 1 upon k plus 1 is positive. Again, numerator is positive, so denominator, which is k plus 1, must also be positive. So k is greater than minus 1. Now if you see, it says k is greater than minus 1. It could still be negative. I mean, the k could be negative, could be positive also. So this one is not sufficient. A is your answer. This question is similar to your rounding off thing. So if I say x is closest to 5, okay, so that means x has to be bigger than or equal to 4.5 but less than 5.5, because 5.5 will round off to 6. Okay, so any value between 4.5 and 5.5, so 4.5 is included. If you see, 5.5 is not included, it will round off to 5. That's the whole thing here. First statement, x plus y is closest to 4. Closest to 4 means it will be less than 4.5 and bigger than or equal to 3.5. Clearly not sufficient because we are talking about x, but it includes y also. We have no idea about y. Second, x minus y is closest to 1, so it's less than 1.5 but greater than or equal to 0.5. This clearly not sufficient, involves two variables. Combine them. So inequalities are same. If you see, let's add the two equations. 2x less than 6 less than or equal to 4. Divide this whole thing by 2. This is what you get. X could be any number between 2 and 3. Now if let's say if x is equal to 2.2, it will be closest to 2. If x is equal to 2.8, it will be closest to 3. So clearly it's not sufficient. Question is, x is closest to which integer? It could be closest to 2 also, 3 also. E will be your answer. Are x and y both positive? First statement, 2x minus 2y is equal to 1. Divide both sides by 2. Now it could be 3 minus 2.5, both positive. It could be negative 2.5 minus negative 3, and this both are negative, so clearly not sufficient. But one thing is clear, x minus y, the difference is positive, so x should be bigger than y. Okay, but still not sufficient. So when I say x is greater than y, so x greater than y will only satisfy this thing. If x is not greater than y, this first statement will not be satisfied. Second, x upon y is greater than 1. Multiply both sides by y. Now if we multiply both sides by a positive number, then inequality remains same. And if we multiply both sides by a negative number, inequality gets changed. So in this case, y is positive, x is bigger than y, so both positive. In this case, y is negative and x is even less than that, so both negative. Clearly not sufficient. So one thing is clear, if x is greater than y, both will be positive. And if x is less than y, both will be negative, but not sufficient. Combine the two. Now first statement will get satisfied only if x is greater than y. So we can eliminate this part of the second statement. I mean, if x is less than y, the first statement will not get satisfied. So if we combine the two, x should be bigger than y, that's one thing. And if x is bigger than y, in second statement, both will be positive. So both positive, sufficient. C is your answer. Is 1 upon p greater than r upon r square plus 2? Now avoid one mistake, which is cross multiply or multiplying both sides by p, because we don't know whether p is greater than 0 or less than 0. We don't know what will happen to the inequality. So what we can do is we can multiply both sides by r square plus 2. R square plus 2 will always be positive. So now this becomes our question. So first statement, p is equal to r. The only thing we can do is plug it here. So that becomes our question. Now remember, it's still a question. We are not solving it, we are just plugging in p for r. Let's say if r is equal to 3, okay, it will become 9 plus 2, 11 by 3, greater than 3, yes answer. Let's say if r is equal to negative 3, so this will become 11 by negative 3 less than negative 3, answer would be no. So it's not sufficient. Okay, r could be positive, r could be negative, we'll get different answers. Second statement, r greater than 0. This alone is not sufficient because it doesn't tell me anything about p. Combine the two, p is equal to r. When we plug p is equal to r in the question, what was the dilemma? R could be positive or negative. But second statement says r is positive. So r square plus 2 upon r greater than r. That's the question. If r is positive, we can multiply both sides by r. Is r square plus 2 greater than r square? Yes. Definitely it is bigger. C is our answer. N is a non-zero integer. Is x raised to power n less than 1? First statement, x is greater than 1. So let's say x is equal to 2. 2 raised to power 2 will be greater than 1. 2 raised to power minus 2 will be less than 1. Not sufficient. The exponent can be positive, negative, anything. Second, n is positive. The exponent is positive. So it could be 2 raised to power 2 greater than 0. It could be 1 by 2 raised to power 2. Greater than 1. 1 by 2 raised to power 2 less than 1. Clearly not sufficient. So in this case, we don't know. The base could be more than 1, less than 1. Combine the two. It says the base is more than 1. let's say 2 raised to power some positive number. The exponent is positive. And this will always come out to be greater than 1. You can check with any number. So as a rule, as a matter of fact, anything greater than 1 raised to power something positive cannot become less than 1. Never. It will always remain more than 1. For it to be less than 1, the power has to be negative. For example, 2 raised to power some negative power can only make it less than 1. So C is the answer here. It will always be more than 1. Now if you check here, is 3 raised to power x less than 500? Now 3 raised to power 5 will be 243, and 3 raised to power 6 obviously will become more than 500. So actually we are checking, is x less than 6? That's a question, if you see carefully. Okay, if the exponent is less than 6, only in that case it will be less than 500, otherwise it will be more than 500. First statement, 4 raised to power x minus 1 is less than 4 raised to power x minus 120. So taking this to this side and 120 to this side. Taking 4 raised to power x minus 1 out, it is 4 minus 1 greater than 120. So 3 dividing both sides by 3 is greater than 40. That's what it means. So see, 4 raised to power 2 will be equal to 16, 4 raised to power 3 will be equal to 64. So x minus 1 is greater than or equal to 3, or x is greater than or equal to 4. That's what we get. But question is x less than 6 or more than 6? We can't say. It could be 5 also, 7 also. We really cannot say. Second statement, x square is equal to 36. So x could be equal to 6 or minus 6, not sufficient. Combine the two. It should be greater than or equal to 4. So x can only be 6. Question was, is it less than 6? Answer is clear cut no. Sufficient. C is the answer. Is x greater than 10 raised to power 10? First statement, x is greater than 2 raised to power 34. Now if you see, 2 raised to power 10 is equal to 1024. That is greater than 10 raised to power 3, which is 1000. Now if you take cube on both the sides, the inequality will remain same. So 2 raised to power 30 is greater than 10 raised to power 9. Now if I multiply this with 16 and multiply this with 10, obviously the inequality sign will remain same. Now this will become 2 raised to power 34. So sufficient. Second statement, x is equal to 2 raised to power 35. Now we have already seen 2 raised to power 34 is bigger. So this is also bigger than D would be our answer. Is the product of two numbers negative? So are the signs different? There will be yes answer. Signs same? There will be no answer. First, y is equal to x raised to power 4 minus x raised to power 3. Now let's say if x is equal to 5, we can say y will be positive, because x raised to power 4 will be bigger than x cube. And let's say if x is equal to some negative 5, y will still be positive. Not sufficient. It could be both positive, it could be different signs. Second, minus 12y square minus y square x plus x square y square greater than or equal to 0. Now take y square out, it will be x minus 4 x plus 3 greater than 0. Again, x is equal to 5, y positive will satisfy this inequality. So that will be both positive case, both signs same. And x is equal to minus 5, y some positive number. In this case, both signs are different. This will also satisfy, not sufficient. Even if we combine them, same set of values or same cases satisfy both the statements. So even combination is not sufficient, E will be our answer. P is less than Q, P is less than R. Is P into Q into R less than P? First statement, P into Q is negative. So one of them is positive, another is negative. And positive will always be bigger than negative. So if I say P is the smaller one, that means P should be negative and the bigger one should be positive for it to be less than 0. But not sufficient because we know nothing about R. Second, P into R is negative again. P is smaller. Smaller one is negative, bigger one is positive. Clearly not sufficient because we know nothing about Q. Combine the two, P into Q into R. P is negative in both and Q into R is positive. How does it compare with P? That's the question. So let's take some value. P is minus 2, let's say. Q into R, both are positive. The product would be 2. In this case, this will be minus 4, clearly less than P. And minus 2 into Q into R, again the product is positive, but it can be a fraction also. It doesn't say Q and R are integers. In this case, it will be minus 1, bigger than P. So clearly combination is not sufficient. Answer is E. The idea here is, if we take a value, let's say x multiplied with some positive value can be bigger than x also, smaller than x also, depending upon whether the value is a fraction or an integer. So this will be used in one more question also. Let's check here. Is MP greater than M? So first, M is greater than P is greater than 0. So M into 2 will be bigger than M. M into 1 by 2 will be less than M. Not sufficient. Again, same rule that the positive number can be more than 1, less than 1. Second, P is less than 1. Let's say P is equal to 1 by 2. Now M could be positive, M could be negative also. So 6 into 1 by 2 will be less than 6. Minus 6 into 1 by 2 will be bigger than 6. Again, not sufficient. The inequality could be anything. Combine the two. M is positive, P is positive but less than 1. So it's like 6 into some value which is less than 1. I know what the result would be. It will be less than M for sure. Sufficient. C would be our answer. When we have exponents, so convert both the sides to exponents. Like 0.04 is equal to 1 by 25, 1 by 5 square, or 5 raised to power minus 2. So 5 raised to power n is less than 5 raised to power minus 2. What we are simply checking is n less than minus 2. That's what we are checking. Okay. First statement, 1 by 5 raised to power n is greater than 25. 5 raised to power minus n is greater than 5 raised to power 2. So minus n is greater than 2. Multiply both sides by minus 1. That's what you get, and the inequality will get changed. This is sufficient. Second, n cube is less than n square. Now this can happen in two ways. Between 0 and 1 also. For example, if n is equal to 1 by 2, so n cube will be less than n square. It can happen in negative area also, like minus 3. Okay, so n could be less than minus 2, like here, but n will be more than minus 2 here. So this is not sufficient. Is 3 raised to power p greater than 2 raised to power q? First, q is equal to 2p. So we just substitute q for 2p. So it becomes, is 3 raised to power p greater than 4 raised to power p? Again, let's say p is equal to 2. So 3 raised to power 2 will be less than 4 raised to power 2. But if p is equal to minus 2, let's say, so 1 by 3 square will be greater than 1 by 4 square. So not sufficient. I mean, the exponent could be positive, negative both. Second, q is positive. Clearly not sufficient because it doesn't tell me anything about p. If I combine the two, what was the confusion in the first statement? Whether the powers are positive or not. Now, q is equal to 2p and both are positive. So we'll have only this case. So sufficient. The powers are positive.